Hi, for this video, we'll be discussing the conics. So this is the first part out of the two parts. For this module, we'll be tackling the circle and the parabola. So let's start. First, for the conics, you can see in the photo here, on the right side, that you have two cones. They're called the upper and the lower naps of the cone. So if you pass, for example, a plane that's parallel to the floor or to the ground, it will form a circle, just like here. And then if you pass a plane that's slanted but only cutting one cone, it will form an ellipse. And if you pass a plane that's slanted but then does not cut through all of the elements of the cone, it will form a parabola, just like here, the blue one on the left and the pink one on the right. Whereas if you pass a plane and then it cuts through both the cones, it forms a hyperbola, the upper and the lower hyperbolas here. So that's why they're called the conics. Alright, so what are the parts of the circle? You can see here on the photo that, of course, we have the tangent line. It's a line that touches the circle at one point. The secant line, a line that crosses the circle at 2 points. A chord is basically just like a secant line, but then a chord is just inside the circle. And then the longest chord in the circle is what you call the diameter. This one is what you call the radius, or it's basically coming from the center to any point on the circle. So the diameter is also, since that's the longest chord, it passes through the center. Here, this is an arc. The arc can be a minor arc or a major arc. If the arc is less than half of the circle or less than a semicircle, it's called a minor arc. Whereas if the arc is more than or greater than the semicircle, it's called a major arc. So this one, just like the pizza slice, is what you call the sector. And then if you cut this, if you connect this line from this point here up to this point, and you cut the triangle, whatever's left here is what you call the segment. So as defined, a circle is a locus of a point, or basically a set of points that moves in a plane so that its distance from a fixed point remains constant. And that distance is what we call the radius of the circle. So let's go to the definitions. Radius is basically the constant distance, just like what I said earlier. The center is what you call the fixed point on the circle. The chord is the segment connecting any 2 points on the circle. The diameter, as I said earlier, is the longest chord of a circle. The tangent line is the line that touches, or basically touches the point of tangency here at one point. And the secant line is a line that intersects the circle at 2 points. So with that, what are the forms of the equation of the circle? We have what you call the standard forms, or the center radius format, wherein here, if you focus on the right side here, if we have the center at 0, 0, typically the first one, the x here is named as h, and then the y is for k. So this is the coordinate for the center, that's h and k. So if the center is at 0, 0, or at the origin, the standard form of the equation of the circle is x squared plus y squared is equal to r squared. Whereas if the center is at any point hk, it would be written as x minus h quantity squared plus y minus k quantity squared is equal to r squared. So for the first example, what is the center? Since nothing is beside the x and the y, the center would be at 0, 0, and then the radius is, you have to take note that when you look here, it is always r squared if it's in the standard form. Therefore, if the right side is equal to 4, that is equal to r squared. So that means the radius is equal to 2. For number 2, the center is at 1, negative 2. Take note that the numbers would have opposite signs. Since this is minus 1, the h is positive 1. Since that's plus 2, the k would be negative 2. And then the radius of this circle would be 5. For number 3, we have a problem because it has 4 as the coefficient of x and the coefficient of y. So what we have to do is first convert it in such a way that the coefficients of both x and y squared are just 1. So this becomes 5 over 4. Therefore, the center is still at 0, 0, but the radius would be the square root of 5 over 2, which is basically the square root of 5 over 4. Here, the center would be 0, positive 3, and then the radius is just the square root of 15. Earlier, I showed you the different examples of the standard form of the equation of the circle. Now let's go to the general form of the equation of the circle. Typically for conics, what you would have is this. I'll just write it here. ax squared plus by squared plus dx plus ey plus f would be equal to 0. We just don't use c because c we commonly refer to c as the center. So for this one, since for the circle, the coefficient of x squared and y squared are the same, we can see that a is basically equal to b. So we can just replace the b here with the a. Or if we divide everything by the coefficients of x squared or y squared, we'll just be left with the one on top, which is simply x squared plus y squared plus dx plus ey plus f is equal to 0. Please take note that a here cannot be 0. Otherwise, if a becomes 0, it's just a line. Okay, so the following here shows the equation of the circle in its general form. So this here, the a is 1. You can see here that the a here or the b here is also 1. So this would be a circle. Later on, I'll show you how to determine if it's a circle just by the general form. Here, this is another of the general form. So for number 3, 4x squared plus 4y squared, this one is also a circle. However, as I said earlier, we're used to seeing it in this form wherein the x squared and y squared are equal to 1. So this one, just divide everything by 4. So that becomes 5/4 equals 0. It's basically just the same. Let's go to the next page. Earlier, I showed you the standard forms of the equation of the circle. You know that the standard form would take x minus h quantity squared plus y minus k quantity squared is equal to r squared. Or if the center is at 0, 0, it would be x squared plus y squared is equal to r squared. So what's left on the right side of the equation is just r squared. So if the r squared, looking at the nature of the roots, is greater than 0, that means there is a graph and it is a circle. Whereas if r squared is equal to 0, yes, there is a graph. However, you will just get a point. Sometimes it's called a point circle. But it's not a circle because it doesn't have a radius. Whereas if r squared is less than 0, there's no graph because you have to take note. If r squared is less than 0, the r would be imaginary. Because the square root of a negative number would contain an imaginary term I. And that means it will not form a circle. So for the first one, let's determine, will it be a circle or not? And if it will form a circle, what are the center and the radius? So in here, the center is negative 3, positive 1. And then the radius is square root of 5. So that means it is a circle. Number 2, we have to complete the square. So here, x squared minus 8x plus y squared. And then let's move the constants to the other side. So that becomes negative 1. So here, negative 8 divided by 2 is negative 4. Square that. That's positive 16. But you have to remember that whatever you add or whatever you do to the left, you have to do to the right to cancel out its effects. So that means this one would then be x minus 4 quantity squared plus y squared is equal to 15. Therefore, the center would be 4, 0, and then the radius is just the square root of 15. Since the radius here, so since the r squared is positive here, the r would be existing, and then it forms a circle. So try the same for the next example. Let's go to the other example. So in this case, reduce each equation of the circle to its general form and then graph it. So in this case, it's already in the standard form, but if you want to make it into a general form, we can definitely expand this. So this would be x squared plus 6x plus 9 plus y squared minus 2y plus 1 is equal to 5. So x squared plus y squared plus 6x minus 2y, and then this becomes plus 10 minus 5 is plus 5 equals 0. So it forms the general form of the equation. However, in order to plot the circle, what we need are the center and the radius. So the center for this one is negative 3, positive 1, and then the radius is basically the square root of 5. So if this is the Cartesian plane, negative 3, positive 1 would be somewhere here, and then take note that the square root of 5 is greater than 2 but less than 3. So let's just approximate. And if you have Desmos and using other graphing medium, you may plot them. So you know that that's greater than 2 but less than 3. So let's just say somewhere here, somewhere there, 1, 2. So a bit greater than 2, 1, 2, a bit greater than 2, somewhere here. So it should form, sorry for my graph, so somewhere here. Now, reduce the equation to the standard form of the circle and find the circumference and area of the circle. So, what is the formula for the circumference? Please take note of this. Circumference is 2 pi r, and then the area would be pi r squared. So in here, let's reduce it first to the standard form. So let's combine all those with x and all those with y. And then all the constants, move them to the other side. So here, negative 2 divided by 2 would be 1. Negative 1 squared is positive 1. Again, whatever you do to the left, you have to do to the right. So here, negative 2 divided by 2 is negative 1. So squared is plus 1. So that one there, you have to also add 1 here. So it becomes x minus 1 quantity squared plus y minus 1 quantity squared is equal to 9. Therefore, I can say here that since my center is at 1, 1, and then my radius is equal to 3, you can plot the circle. So the circumference is 2 times pi times the radius. So that means this circumference is 6 pi units. And then the area is pi r squared, or 9 pi square units. So for the next one, let's divide everything by 4 first, or let's just divide it later on. So 4x squared minus x plus 4y squared plus 6y, and then let's move the 37 to the other side. So here, 1 divided by 2 is 1/2, so negative 1/2 squared is positive 1/4. And then in here, 6 divided by 2 is 3, squared is 9. But then you have to take note that that is 4 times 9. This is 4 times 1/4. So you added 4 times 1/4, or 1. So I have to add 1 here. You added 4 times 9. That's 36. So I have to add 36 to the other side as well. So in here, it becomes x 4 times x minus 1/2 squared plus 4 times y plus 3 squared is equal to, so that is 0. So even if you reduce this, x minus 1/2 quantity squared plus y plus 3 quantity squared, 0 divided by 4 is still 0. Take note that the r squared is equal to 0. That means it's not a circle, it's just a point. So for this one, it's not a circle. These examples. And now, so for this one, we have the opposite. What we're given are the conditions, and then we have to determine the equation of the circle. So in here, find the general equation of the circle with center negative 3 and 1/2. And you're not given radius. So let's just say, since we're not given any radius here, let's just say radius is 3. Okay. So, since C is negative 3, 1/2, radius is equal to 3, x plus 3 squared plus y minus 1/2 squared is equal to 9. So this one is your standard form. However, since you're asked to solve for the general form, let's expand this. This would be x squared plus 6x plus 9 plus y squared minus y plus 1/4 is equal to 9. Let's multiply everything by 4. 4x squared plus 4y squared plus 24 x minus 4y, so 9 times 4 is 36. 9 cancels out, so that means this is plus 1 equals 0. So I guess I'm correct here. So this would be the general equation of the circle. Now here, find the general equation of the circle if its diameter has endpoints negative 3, 1, and 2, 4. So you're given the diameter, but you don't know the center. Do take note that what is the diameter? The diameter is the longest chord that passes through the center. So I could say here that the center is actually the midpoint of those 2 points. So let's solve for the center. What's the formula for the midpoint? Isn't it x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Therefore, it would be negative 3 plus 2 over 2, 1 plus 4 over 2. So this one, negative 1/2, and this is 5/2. The thing is, you know the center, but what is the radius? Maybe we can use the distance formula to solve for the diameter, and then just divide it by 2. So let's solve for the distance. X2 minus x1, so that becomes 5 squared. Y2 minus y1, that becomes 3 squared. So this is 25 plus 9 square root, that's a square root of 34. But this is the diameter. Therefore, the radius is square root of 34 divided by 2. So if I ask you what would be the equation of the circle, it's going to be x plus 1/2 squared plus y minus 5/2 squared is equal to 34 over 4 because I squared the radius already. And then expand this to get the general form. So I'll leave you here with the standard form of the equation of the circle. Okay? So to continue, find the general equation of the circle with center and passing. So this is easy. You can just get the distance formula to solve for the radius. You already know the center. That's easy. I won't give you that. Find the general equation of the circle with center, 2, 3, and tangent to the line. So since you're given the tangent line equation, what can you do? Do you still remember how to solve for the distance between a point and a line? So how do you solve for that? Isn't it that to get the radius, that's actually distance from point to line, which is actually ax plus by plus c all over square root of a squared plus b squared. The distance here doesn't really matter, although we, as I say, we usually take the sign of the b, but then it doesn't really matter. It just tells us where the point is located, if it's above or below. So using this equation, 3 minus 5 minus 8 all over negative square root of 9 plus 25. So for the parentheses here, what we use are the 2 and 3. So I'll just use a different colored pen for that. So here, 2, this is 3 coming from that one for you to remember. Okay, so let's continue on. I'll just use blue. So this becomes 6 minus 15 minus 8 all over negative square root of 34. So 6 and 8 is negative 15 minus 8 is negative 23 plus 6 is negative 17, right? Over negative square root of 34, or simply 17 over square root of 34. So this one, if we cancel, that's all over 2. So you have the center, you have the radius, so this is x minus 2 squared plus y minus 3 squared is equal to the radius, which is 34 over 4. This one, because the radius here that we got is square root of 34 all over 2. So when you square that, that's it. Okay? So basically just get the general form of the equation here. Now, for the example here, you're given points A, B, and C. You have to remember that one of the forms of the general equation is x squared plus y squared plus dx plus ey plus f is equal to 0. So in this case, what we do is using equation number 1, negative 1, negative 4, let's plug it in the general form. So 1 plus 16 minus d minus 4e plus f is 0. So when you simplify this, this becomes minus d minus 4e plus f is equal to negative 17. This becomes your equation number 1. And then let's plug in the second point, which is point B. So that becomes 9 plus 4 plus 3d minus 2e plus f equals 0, or 3d minus 2e plus f is negative 13. This is equation number 2. And then lastly, using the third point, which is 5, 2. So this becomes 25 plus 4 plus 5d plus 2e plus f equals 0, or 5d plus 2e plus f is negative 29. So that's the third equation. So it's up to you. I usually just cancel out letter f first because the coefficients of ff are basically 1. So just solve simultaneously. You've learned that in your general mathematics. And then solve for the equation of the circle. So we'll end the circle with this one. If you have any questions, we will be discussing this in the synchronous classes. So please review well. Thank you.